So, write a sum to represent the future amount of a structured savings plan if you deposit $250 in an account each month for 5 years. It pays 3.6% interest per year. Find the value of the investment after 3 years. Okay, so this is the sum of the sequence, or the sum of the series. And actually, I think we're just going to skip it for now. Sorry. I want to make sure we talk about and we get to all these things in a faster fashion. Yesterday, we talked about growth and decay. So we talked about annual growth. When we talk about money, most of the time we're going to be talking about annual growth or annual percentage rates, annual APRs, annual percentage rate. So in annual growth, we use the basic growth formula where this is the final and this is the initial, or we call it the principal when we have money involved. R is still the rate, and T is time in years. Okay, so that's the formula you know about. There's also something called continuous growth. So most of the time this has to do with science, rate of growth of bacteria or rate of decay of some isotope. So when you see the word continuous or compounded continuously, you need this formula, which is the same as the other one, except instead of 1 plus R, we have E, which is just the base E, just the number. R is still the rate as a decimal. We should write decimal here. T is still time. And P is still the principal or the start. So all the things are the same. Then the other types of compounding has this other formula here. So it says other. If you notice, if you were to get rid of the ends here and here, don't scribble them out. If those weren't there, it would be the basic growth formula. The initial 1 plus the rate times time. So the reason this one is here is because sometimes interest is compounded more times. So if you have something that's compounded instead of once a year, but maybe twice a year, or 4 times a year, or monthly, so 12 times a year, or weekly is 52 times a year, or daily, which is 365 times a year, depending on the year, then you would need this formula. So the interest rate is affected, if you notice here, the interest rate is affected by the number of times it's compounded, but so is the time. So that n value has to be put in 2 places. So really what we need to make sure is that we know what kind of numbers we're using for n. So if it says quarterly, quarter means n is 4. Monthly, you should know that there are 12 months in the year. Yes. Semi-annual means 2, means twice a year. Beyond that, it should tell you. Okay. So basically you have to remember these formulas and know when to use them. Otherwise, the math part is the same. Setting it up is the same. Solving is the same. Everything's the same, except for which formula you're going to use. So we're going to start with a straightforward example here. Matt deposits $2,900 from his piggy bank into an account that pays 3.5 annual interest. Find the balance after 3 years if the interest is compounded monthly. So we have a final amount of an initial amount of $2,900. So that's our principal or our initial amount. The interest rate is 3.5%, so our decimal is 0.035. And it's asking after time 3 years, okay? But it says compounded monthly, which means we have n equals 12. So that means we're using that other formula. So A equals T, parentheses, 1 plus the rate divided by the number of times compounded, raised to number of times compounded times time. So A is equal to the initial amount, 1 plus R is 0.035 divided by 12, raised to the 12 times T is 3. So we're going to go to our fancy calculator. So 2,900, parentheses 1 plus, so I have to make this bigger here, control divide, 0.035 divided by 12, raised to the 12 times 3. So $3,220.57. $3,220.57. They didn't give me rounding directions, but they didn't have to because it's money. Money is always true. Okay. I think my microphone is broken. All right, so compounded annually. That means the number of times compounded is 1. N equals 1. So all of the things are the same, except n is equal to 1. So if n is 1, then r divided by 1 is just r, and 1 times time is just time. So it's our basic growth formula. 1 plus r over 1 is r, or r over n is, yeah, r, what did I just say? R over 1 is r, yes. And then 1 times t is t. So all of the things are the same. We're still starting with $2,900. We're still investing at a 3.5% interest rate, and we're still checking it out after 3 years. So let's see what happens. Let's see which is better. 2,900, 1 plus 0.035 to the third power. $3,215.28. So $3,215.28. So where do you want to put your money? Do you want to put it in an account that's compounded monthly or annually? Yeah, you make $5 extra for doing nothing if you put it in the compounded monthly. So the more number of times it's compounded means you're earning interest on your interest. So after a month, even if you've earned an extra 5 cents, you're then earning interest on that 5 cents forever again, forever and ever and ever. So compounding more is better if you're saving money. It's worse if you're spending money. Okay, let's go to the next one. Joe deposits $5,000 into an account that pays 3.72% annual interest. Find the balance after 4 years if the interest is compounded quarterly. Okay, so as soon as I see this, compounded quarterly, I know n is 4, so I'm going to need the formula that has the n in it. So it's A equals P, parentheses 1 plus. All of that's the same from yesterday. R over n to the nt. Okay, so the initial amount, P, is 5,000. 1 plus, the rate is 3.72, so move that decimal twice. Oh, my computer doesn't like that. 0.0372. 0372 over n is 4 to the 4. Gosh darn it. And then it says, so n is 4, we're finding the balance after 4 years, so t is also 4. Cool? So we're going to calculate that. All right, so 5,000. Gosh, I hate when I don't click it right. 5,000. 1 plus 0.0372 over 4 raised to the 4 times 4. $5,798.22. We'll round up. Yeah? $5,798.22. Easy peasy. Okay. Now, college savings plans, such as the 529 plan, allow individuals to put money aside now to help pay for college later. Smart. If one such plan offers a rate of 4% compounded continuously, not basic growth, not compounded n times, compounding continuously. If you want to remember this formula, call it PERT. Continuous dandruff relief with PERT plus. So continuous compounding interest is with P E to the R T. Yes, I'm a dork. Okay, just checking. Keeping it real, kids. Keeping it real. Okay, so let's see. There's our formula. It says how much should be put in the college savings plan in 2005 to pay for 1 year of the cost of college, $31,000 in 2015. Well, now make it more complicated. Yeah. So first of all, what's our rate? R is 4%, so 0.04. It's asking us for an amount, right? How much should we put in? So it's asking for P, and it's saying we're going to put that money in 2005, and we're going to take it out in 2015. So it's telling us that time is 10 years. E is just E, you know, E, 2.71-ish. So we want $31,000 in an account after 10 years at an interest rate of 4%. Yes? Okay. Normally I tell you to get the weird thing alone, right? What you are not realizing right this minute is we're solving for P. And this thing with the E to the 0.04 times 10, is all just a number. That's a value, isn't it? So I'm going to divide by E to the 0.04 times 10. Divide by E to the 0.04 times 10. And that will give me the principal or the initial amount that I need. So let's go to the fancy schmancy calculator. $31,000 divided by, you have to use the E key, not the keyboard, 0.04 times 10. So in 2005, I should have deposited $20,779.92. $20,779.92. 779? Yeah. Pretty sure in 2005, I didn't have $20,000 just like sitting around in my bank account waiting to be deposited and saved for college. Okay, college is expensive. Get scholarships. Write the scholarship applications. Get financial aid. And make sure that your debt to income is appropriate. So if you are going to go to school to be a math teacher, it wouldn't be smart to go to the U of R and pay $60,000 a year because you're not going to make that in 1 year teaching when you first start. Just saying all the things. Okay, in a savings account with an initial balance of P and an annual interest at R that is compounded continuously. So as soon as you see those words, continuous dandruff relief is with PERT, PE to the RT. If the initial balance of the account is $1,200, so we have P, we know E is just E, the number, the key. Find how many years, so we're solving for T, to the nearest tenth of a year, it would take to arrive at a balance of $3,200 if there's an annual interest rate of 8%. So R is 0.08. So r is 0.08, and then we're solving for t. Okay, so here's that whole thing where I tell you, this is just what you did the other day for your homework. It's what we've been doing for 2 days. You get the weird thing alone. E is clearly the weirdest guy in the room, right? So in order to get E by itself, we divide by 1200. And I know your calculator happy, but my brain says just cross those zeros out and leave it as 32 over 12, because it's probably easier to handle than some ugly decimal of some sort that I don't even want to copy down. So now, 32 over 12 actually probably works out pretty nice, doesn't it? Yeah, it does. Okay, sorry. So now, we don't want to get a common base because our base on the right-hand side is e, so we have to change the form. So log base e of our fraction, 32 over 12, is equal to 0.08 times t. Don't do anything in the calculator yet. We're going to divide by 0.08 to solve for t. But also, log base e is actually ln, so 32 over 12, and we're dividing by 0.08, so divided by 0.08 will be equal to t. So let's find out how long it takes us to get $3,200 at 8%. So get a fraction, natural log, because it has a base of e, 32 over 12 divided by 0.08. 12.26, and it said nearest tenth, so t equals 12.26, which means t equals 12.3. So, hey, you're paying 8% for doing nothing. I'll take it. Okay, so these next grouping of questions are meant for you to try. No, they're not. Just kidding. They're solving. Okay. So, to the nearest tenth, anytime you have rounding directions, you should probably highlight them or circle them or underline them. How long will it take $5,300 to become $7,000? So we're starting with this. We're ending with this. If it is invested at 9%, so R is 0.09, and compounded quarterly, N equals 4. So now you have all that information, but you also have to be able to set it up. You have to know A equals P, 1 plus. That part should be, no matter what, you should have that down. It mentions an N value, so it's R over N raised to the NT. Okay, so we have A is 7,000, our final amount. P is 5,300, our initial amount. 1 plus 0.09 divided by 4 to the 4t. Cool? Let's see if 0.09, 1 plus 0.09 over 4, we can like simplify that and make it look good. 1 plus 0.09 divided by 4. Okay, it does terminate. Let me just make sure my settings. Yeah, I think I'm good. So let's rewrite that number. Sometimes it won't be a nice number, so 1.0225. So we have 7,000 equals 5,300, 1.0225 to the 4t. That's going to be easier to handle in a minute. Okay, so our next thing is we have to solve for the exponent. So get the weird thing alone. Divide by 5,300. A couple zeros go away. So 70 over 53 is equal to 1.0225 to the 4t. Clearly, we're not getting a common base with that fraction and that decimal. We're busy. So we're going to change the form. Log, your base is 1.0225 of 70 over 53 is equal to 4t. The last thing we got to do is divide by 4, so I'd rather just put this in the calculator all at once. I don't know about you. So let's check it out. Get a fraction here. Log base 1.0225 of 70 over 53 divided by 4. 3.1257. Where did it want us to round to? 10th. So 3.1. So t equals 3.1 years. Fabulous. Okay. Ooh, I love this question. Oh, I'm so excited. Oh, I'm so excited. Okay. Sorry. To the nearest 10th, again, rounding directions. How long will it take a sum of money? How come you're not telling me how much it is? To double if it is invested at 12%, so R equals 0.12, and compounded annually. N is 1. Well, so you're going and you're saying, okay, well, final equals initial. 1 plus R over 1 is just R. 1 times T is T. But they don't give me an A and they don't give me a P. They only give me an R. What is happening, right? So a sum of money, meaning it doesn't matter, okay? It doesn't matter what number you pick to start. So you can say, okay, you're going to invest $2, or you're going to invest $1,000, or you're going to invest $50. It doesn't matter. Nobody cares. So pick something that's easy to work with. If we say that P is 10, let's say, we're looking for when the amount of money will double. So that means A is 20. So use numbers that make sense and that are easy to work with. So A is 20, P is 10, 1 plus 0.12 raised to the T. Yes, I know what that is. 1.12 to the T. Okay. So we have to solve for time. I hope you're looking at that and you're saying, get the weird thing alone, so divide by 10. And you get 2 equals 1.12 raised to the T. And then I hope you're thinking, oh, you log it. So log base 1.12 of 2 is equal to T. We're rounding to the nearest 10th when we put this in the calculator. So log 1.12 of 2. 6.11, so 6.1. 6.1 years. Okay. So those are all the ones where you have to memorize the formula. Then sometimes the formula is just given to you. I feel like there's something missing here. No, there's not. So sometimes it's just given to you. Okay, so during surgery, a patient must have at least, I sometimes think you guys don't understand the definition of at least. That means minimum 40 milligrams or more, okay, of an antibiotic in his system. The amount of antibiotic present K hours after administration of 100 milligrams, so whoop, 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 there's our beginning, is given by this function. And now, so they're messing with you. They're calling it K instead of T, because why not? P of K is 100.508 to the K. After how many hours, so we're solving for K, to the nearest 10th, there's our rounding directions, will the nurse have to administer another dose of the antibiotic to keep the level of antibiotic high enough? So we have to stay at 40, which is what we're going to call our final amount. So this will be on the left, P of K. So 40 is equal to 100. They did that part for us, so good thing. 0.508 to the k. Now, I've seen it before where they ask you to explain what does the 100 represent, and you have to know that that means the initial amount. What does the 0.508 represent? You would have to know that that represents decay and that the amount is decreasing, right? So it's decreasing in his system by whatever percentage, okay? So we are solving for k. So the first thing you want to do is get the weird thing alone. So we're going to divide by 100. So 40 over 100 is 0.4 equals 0.508 to the k. The only way to bring down that exponent is to change the form. Log base of 0.508 of 0.4 is equal to k. So let's see how long it takes before he needs more antibiotics. So log 0.508 of 0.4, 1.35 something, and it said nearest tenth. So k equals 1.4, yeah? So let's see if that works. At 1.4 hours, he's got 38. So let's say 1.3 will round down. 1.3, because we don't want him to get sick. Let's see here. Copy that. There we go. Okay, because he has to have at least, so 1.3 hours. Because once he gets to 38, it's gone too low. Okay, so let's go to this. I think this is the last question here. An exponential model of a population growth is given by P of t equals P sub 0, 10 to the kt, where P0 is the original or initial population and t equals the number of years that have elapsed. The population of a culture is 2,000 now and is 4,500 in population of a culture. Oh, you know what? I bet this was a question about bacteria at first. In 2 years, then what is the value of k to the nearest thousandth? So this one's a little bit different. So we have 2,000 now and 4,500 in 2 years. So this is P sub 0. This is our final amount, P of t, after t equals 2, and we're solving for k. So 4,500 equals 2,000, 10 to the k times 2. All of the rules remain the same. Get the weird thing alone. So divide by 2,000. What's that? 45 over 20. I'm just going to leave it for now. I could do the math in my brain, but I'm tired. 10, and it doesn't matter, to the 2k. So we're going to change the form. Log base 10 of our fraction is equal to 2k. Solve for k, so we're dividing by 2. And then type it in. You need to round to the nearest thousandth. Tens, hundredths, thousandths. So we need to round to 3, so we look at 4. Log base 10, 45 over 20. Oh, I should have done, oops, I'll do that. And I don't like doing this separately, divided by 2. So we need 3 decimal places. 0.176, I look at the fourth, it's a 0, I stay at 0.176. K equals 0.176. Yay! Okay, that's it. Congratulations! So you need to memorize. Whoa, that was weird. Did you see that? That was weird. Okay, so you need to memorize these 3 formulas and when you have to use them. Okay?